Okay, so I'm recording this. So today what you're supposed to do is control flow, but before we get to that, I wanted to explain what Faith was doing with the input and all that, so that we understand why are we using float, and somehow she used it without fully understanding what it means. But also that's also the good thing of trying to do things on your own, so that when I'm explaining here, it's a bit easier for you to catch up. Where do I keep your projects? So today, I just want to explain this. Let me just explain this. So today's, okay, we did day 4. That was operators, variables, and all that. So let me just explain it here. We did something to do with type conversion. Oh, actually can explain it with this one. You can see what I did here with the edge. So let's do this. I want to comment this out. Now, what normally happens is that whenever you type anything or you collect user input using keyboard, be it on screen keyboard or just your computer keyboard, it doesn't matter. Whenever you pick user input using the keyboard, the input is read as string. And if you look at the string some of the string operations is that you can actually combine two different types of two different strings into one. For example, so that you to make sure you understand this, let's say
Are you sharing your screen? Because we are not able to see it.
I thought I was sharing. Thank you for that. I wasn't sharing. Okay, so let's say, for example, we have string operations. I want to go through this really quick. So let's say we have string 1 or sentence 1. Let's say just sentence 1. Hello. And then we have sentence 2. Something like that. So I could actually combine, I can say S3 equals to S1 plus, then add some space. So string is a space, add some space, and then S2. So probably what that is going to do is combine those two strings. Now, if I do 12 and 30 or 43 as string, even without using this, let me just combine them directly, like S1 plus S2. It's going to combine them. It's not going to see, because they are seen as string. So it's going to combine the two. So if I run this, you'll see something like, let me go with this. So if I run this, you're going to see 1243 as S3. You're not seeing 12 added to S3 because when you combine two strings, it will pick the first one and then combine it with the second one, whether they are numbers or whatever. So long as it is within quotes, it is string. I can do the same thing with hello, hello world. And now if I run this, you're able to see hello world combined. But if I want space in between, then that is where I string 1, add space, then add string 2. So in between space will be added as a character. And now you can see there's a space between hello world, hello and world. But we also have some string operations like I can say s1 dot capitalize. Actually, let me just use print. So we have a lot of s1. You can say uppercase. So let me just say upper. So I can say s1 dot upper, and that will change s1 into uppercase. You can see now it is in uppercase, or I can do dot lower, and that will return lowercase. Or I can say print s1 if s1 dot ends with O, else s1 dot upper. All right, let me see if I can. So what I'm doing here in Python, it allows you to write inline if-else statement. So I can, this is something that you can explore for later if you're interested in Python, or of course, if you'll be doing an advanced course in software engineering, probably we'll do advanced version of this course. But you can see here, I'm going to print S1 if S1 ends with O, but does it end with O? Does it? Yes, it does. So let me say R. If it ends with R, then I'm going to print it. Otherwise, I'm going to print it in uppercase. So you see, for the first scenario, it was ending in O, so I printed it in a lowercase, the way it appears here. So let's see. So this one prints it in upper because it doesn't end with R. So it will print it in upper. You can also do S1 dot is lower. So in this case, I want to check if that string is lowercase. Maybe in a scenario where I don't even know if the string will appear in uppercase or lowercase. So if it is lower, and then what do? I want to maybe print it in uppercase. Actually, if I'm going to print S1, if it is in lowercase, otherwise I'm going to print, I'm going to change it to uppercase. So let me just try to run that again. Now you can see this is camel case. This is not lowercase. It starts with a capital H. So it's probably going to print it in uppercase. There are more functions, actually. There are more functions. So one of them is, let me just try to explain, is upper checks if the string is uppercase. Capitalize is going to capitalize the first letter of that particular string or change it to camel case. Or if it is a sentence, it's going to capitalize. And then you can find a letter in a string, or you can find a certain pattern in a string. Dot format, I think I already talked about dot format. You can format a string to include some variables within it. And I gave you two options, using the F at the beginning of the string or dot format at the end, and trying to arrange your variables that you want to show within the string. And then we have a common function called index. So I want to find the index or the position where maybe L appears. Or let me say E. So if I do that, so okay, let me try to print that. So let me try to print index of E. Or let me just say position of E. Position of E in S1. And that is going to give me 1. Why do you think it is 1? Can somebody explain why the position of E is 1 but not 2? There's something I told you in our previous class. Why do you think the position of E is 1 but not 2?
Because
Yes.
the letter E in hello is we only have one letter in the word hello.
Yeah, we only have one, but now what we are looking at is the position. See, how many letters do we have here in hello? Just say it. Just unmute and talk.
5.
We have 5. So, uh, so this is 1, 2, 3, 4, 5. But why do you think E is at position 1, but not 2?
We start counting from 0.
Exactly. So remember when I said programming will somehow change how you see things and how you count and the general mathematics that you're told. In programming, most of the time, 0 matters a lot. And when it comes to lists, dictionaries, whatever, you start counting from 0. Whichever language you'll be learning, whether it's Python, C, Java, you always start learning counting from 0 when you are considering positions. And this will come in handy when you're building bigger systems and you really or doing data analysis and you really want to find something at a particular index. So if you see, if I find the index, so if you don't know, try to use if it is a string, try to find the index and you'll see. So actually, if I find the index of H, it will give me a 0. So that means it starts counting from 0. What if I do H? Does that exist? No, that doesn't exist. So you also need to learn how to solve your error. So it's telling me the last one here, value error, substring not found. So it gives you the problem. So whenever you meet a problem like this, just scroll to the bottom and look at that is normally where the error is found. Hii gibberish mingi achana nayo. Now the real error here is here. Substring not found. That means H is not found in hello. So it can't print it. Okay, let's look at another function. So you can say I can actually let's explore the split functions of string. So s.split E. Now, what this does is, if you're using VS Code and you put your cursor here on top of split, it will try to explain how the split function works. So returns a list of substrings in the string using the separator as the separator string. So, for example, from that you're able to see that if I say split, it will split where there is an E, and then let me just write here results. It's easy. So if I run this now, what is going to happen is that it's going to split this string S1 and return a list of the different substrings. But it will split where there is an E. So E is not included in the resultant. So whichever string it prints here will not be, E will not be included. But what happens if I just say split? What happens if I just say split? Now, generally, when you split a string without specifying how you want to split it, it's going to split it letter by letter, assuming that, okay, let me just do this first. So you can see here, we have one hello. So I did not specify how I want to split my string. So what happens? It's going to go through each of these letters, and then in my split, I did not provide any directive of how I want to split my string. So it's going to do it. Sorry, word by word, not letter by letter. It's going to do it word by word and return a list. Now this list only has one item. So let's try to do it. Hello there. And let's see. Can somebody guess what the answer will be? If I split this without specifying how I want to split it. Can somebody guess what the output will be? Just unmute and talk.
Hello. Then in another line there.
Okay. So hello and there. So if you don't specify by default, it's going to split where there is a space. Let me put it that simple. So if I have hello there, how are you? It's going to split it where there is a space or word by word, something like that. So you can see it as this is split into different words. But you can specify that you want to split. Let's say if I say I want to split where there is a comma. Can somebody guess what is going to print now?
Hatuoni terminal yako vizuri. Ongeza juu kiasi.
Hamfai kuona terminal yangu, mnafaa kuona. Alafu sasa, let's see. Okay. No, I was having that. Is that better?
Yes.
Good. So now that I'm splitting where there is a comma, what happens?
It will print all of it.
Terminal split.
All right. So it's going to print all of it because actually it looks at, it's going to try to find a comma in my string. If there is no comma, it's going to just return the whole of that sentence. So you can use the split to do so many things. And I want to give you an example. You can say, let's say I want to add 3 numbers. Let me say, and I'm going to say, put enter list of numbers separated by space, and then I'm going to split. Then I'm going to sum them. So instead of maybe collecting one number at a time, I can actually collect numbers separated. So I can separate by space, but I can also say separated by commas. So when I do this, I can run this application. Oh, okay, sorry. So you can see. So when I'm splitting, because I'm going to separate by commas, I'm actually going to split where there is a comma. So let me try to run that again. So I can enter 3, 5, 6, 7. Now you can see the sum of the numbers is in the list is 21. It's combining all this. So it's splitting where there is a comma. Once that is done, we are using a for loop. And that brings us to loops, what we are learning today. Looping through all the numbers in that list, because if you split a string, remember I told you now you're combining the knowledge of the previous classes. I told you that anything that you pick from your keyboard through the input function comes as string. So if you enter the numbers 3, 5, 6, 7, they are actually read as string. And because we have the split function for a string, you can actually split those numbers. And because what we are trying to do is add the numbers, you need to change them back or use what we call typecasting and change the numbers into integer or float. And I think we discussed this. So once you change the numbers, each number that you loop through here, you're changing into integer, and then you add it to sum. Initially, sum is 0. So if you are at number 3 and you add it to 0, you get 3. If you are at number 5, you add it to, now sum becomes 3. You add it to 3, it becomes 8, all the way to 21. So those are some cool features that you can try with string operations. And you can actually read more about string operations. But for this course, it's a short bootcamp and we're not going deeper. So that brings us to what we are doing today. So today we are doing control flow. Okay, so now when we started by talking about variables, data types, and then we moved to operators. So like I said in my previous class, or in our previous class, once you have data, or once you have your containers, the variables, and you have data in them, that data is not just sitting there for fun or for just looking at or something like that. The reason why you declared that data or stored that data in that particular variable in the first place is because you wanted to perform some operations. So we had already discussed the different operations, and you are able to build actually a small or a simple calculator. So we realize that if you have data, you can actually use operators to manipulate the data. But can we go a step further and try to control how data flows in your system, or how you manipulate that data? So that will bring you to control flow and loops. They are actually operations that you are performing more than once. So do you want to print like write print statement like 10 times when you can actually use a loop? So you already know that this print statement is repeating like 5 times or 10 times. So you write it once, but you use a loop that is actually able to print it 10 times the way you want. So we are trying to make things easier by using a control flow. So as much as it's going to control how you manipulate your data, it's also going to allow you to shorten your code by ensuring that operations that repeat can actually be put within a loop, so that you don't have to write them several times. So we've looked at a number of if statements. We've looked at for loops, but you are not aware that we are doing loops at that moment. So now I just want to do it in this class and explain further. So we can have, when you're talking about loops, let me just say control flow and loops. And loops. So we have if-else statements. Let me just list them. And if you did that project where you made the simple, so we have just if condition and then the code block, and then we also have elif, and then we have your code block, and then we have else, and you can have it. So this if else, you can have them nested depending on the number of conditions that you're checking. Then we have for loops, that is under loops, and then we have while loops, and we have, what do we call them? We have something called break and special statements. We call them special statements. Break, continue, and pass. So basically, this is what you're doing today. And then later on, maybe we can introduce functions and object-oriented programming. But I want to focus on this today. But being that we've tackled this before, I think it will be, we won't spend much time here. It will be straightforward. So let me start with if-else statements. So here you have to, you're only checking. Okay, let me say, let me put it that way. So you might be having, you are going to use if statements based on the decisions that you have at hand. You have, you only have to make one decision. The other decision is automatic if the first decision fails or is not valid. For example, let's start with if condition. That is one way. So if I only have one option, and let's say A, Now, if I only have one option, so you're going to input day, I'm converting that to integer from 1 to 7. If it is day 1, I'll say Monday. So I'll do this. I'm choosing that because I might have two-way or multi-way. So for the first option, if condition, just one if, that means I only have one condition. I'm only checking if that day is Monday, and then I'm going to print Monday. I'm not checking anything else. So we don't have else part. So for this scenario, if I just try and input 2, then you can see nothing is being printed. Why? Because I'm only checking one condition and I did not type 1. So if I type 1, you can now see it is printing. It's printing Monday. Option 2, now we have like more than one condition to check. So you can have 2 if and else conditions, or if and else conditions, if else conditions nested without an else. That is if there is no default option. So the else represents the default option. For example, I can say you can come with a friend. But if I say you can come but not with a friend, or if I didn't specify, I just said you can come with a friend. I did not specify whether there are, if you don't come with a friend, you can't come, or if you come with a friend, something else happens. I didn't specify that. So that means it's not a must to have an else condition or a default condition. But you can have it depending on whatever you're dealing with. Because I saw a program here, the one that Faith was presenting, where we had else condition at the end, so that if you try to input something that is not in her list of operators, then you'll get the message that is not a valid operator, or the operator is not supported as at now, something like that, so that you direct your users appropriately. So let's go to the second option here, where now we can check multiple options. So I can say, so if it is 2, then it is Tuesday, and I can continue checking. And then we can have maybe the else. So else here will print. If it is not in these options, the number should be between 1 and 7. If it is not within those options, then we can say another day. But there's something that I also wanted to talk about, nested. We have nested if and else and all that. So let's say you wanted to check if day is Monday, but I don't just want to print Monday. If day is 1, I can do another check. What do I do on Monday? So if day is Monday, and so let me have something here also, and month. So I can check here, if day is Monday, then I can go ahead and check month. So if month is 1, I can say something like that. It's New Year's Day. So you can see these are nested if. The first if checks day. The second if checks another condition, which is month. So you can do anything here. You can if you needed to check another condition here before you maybe execute this code block. So the first check here, and then you're going to go to this code block, the second if code block, and you're also going to check this. If it resolves to true, and then you're going to now execute this. So that is nested. And then you can see this if statement as an else if condition. So what if day is equals to 2? Then you're going to print Tuesday. If you wanted to check something under Tuesday, before you print it, you can also do a nested check. So the same can apply to any other. So it can apply to if statement. It can apply to else if block. Yeah, so I think basically this covers the if statements in Python. Like I said, I'm not going to go that deep because this is just a boot camp. Yes, David.
Asking, suppose if you want to nest inside elif,
Uh-huh.
we use still if or we use else.
Now, I want for us to understand this, I want somebody to give me a scenario of maybe something that you want me to solve using if statement, a simple program. And then we can do it here so that we make sure we understand if, else, and the looping. David, probably you. Just think of something simple that we can do using if. I mean, we are checking conditions, something that may be a decision that you make on a daily basis, but you want to now see if you can automate it. You can automate it using control flow.
If day is Monday, go to work.
Go to work. Okay. So day, and then we are going to say if day is equals to 1. Actually, that will not give me a nested if, but let me just do it. So I'm going to say if I don't know, somebody can think of something crazy kidogo tufanye. What do you want to check again? David, you have something crazy. Is it David? Yes, Faith.
If the day is Monday
Hmm.
and it's raining, then we won't go to work.
So we have day and we have weather. So whether you have two options, sunny or rainy. Okay, so you can say the first one, you can say if day equals to 1, print Monday, blah, 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 all that. So I think, let me end it here. Let me do an else. End it there. Okay, so this is like, so if day is Monday, you're going to print Monday, but you are going to the next check. If weather is sunny, then go for walk. Otherwise, you stay indoors. And then we go to day 2, which is Tuesday. If it is sunny, then go for a walk or stay indoors. So actually, let me just not repeat this. I can do it in one else because what, okay, let me leave that one. So what David wanted to see was how do you nest inside the elif? So I have elif, day is Wednesday, and that is day 3. And I'm checking the weather. If weather is sunny, using an if statement. Is this what was confusing you? So that we
Yes.
clarify.
Yes.
Now I have elif. So think of a real world scenario where you have to decide, you have to make a decision. Si complicate hapa venye tutarudi hapo kwa hiyo code. So think of a normal day where you have to decide. You woke up and it's raining. So you want to make a decision. I wanted to go for a walk, probably by 8 a.m. But I can see, or maybe for a morning run, but it's raining heavily. So what do I do? So the first scenario is you normally go for a run in the morning, right? Every Wednesday in the morning. But that particular Wednesday when you woke up, the first decision was check if the day is Wednesday. And yes, the day is Wednesday. And you're like, oh, it's Wednesday. I should be going for a morning run. But the moment you open your door, it's like raining like crazy outside. So you have to make the second decision. But because days of the week are 7, so that means you had the first if, which was checking the first day of the week, which was Monday. So there is now like telling a computer, because a computer has to know that there are 7 days to select between. So it's going to check if that particular day is Wednesday. So let's take this into the context of an alarm. You normally set an alarm on Wednesdays to wake up at 8 a.m. to go for a run. So that is a computer program. But if it is smart enough, it is able to integrate with some weather microservice. It is going to check before ringing that alarm. It's going to check if that particular day it is raining, and if it is really raining, then instead of ringing that alarm, it's going to just send you a notification that you have a missed alarm. Allow me to maybe reschedule your morning run to this particular day. Today it is not a good day because it is raining heavily in your area, something like that. So if you are to do a smart program to control where maybe how your alarm is going to ring based on the day and also the weather conditions, then something like this will suffice. So umenielewa David?
Yes, nimeelewa.
Yeah, so that means you can actually have an if statement inside an elif. And you can even have more options here, like another elif here. If weather is raining, then take an umbrella. So it's advising you further. You can go for walk, but you need to take an umbrella. So it doesn't matter. It is nested. You can nest it however you want, so long as you're checking, depending on whatever scenario you're trying to depict. So if you are good there.
Yes, I'm okay.
All right. So now we can go to loops. Now, so think of that scenario. When we started this, let's say we are preparing a meal. So let's put it in that context. When we started, we said when you're preparing a meal, you have your ingredients in containers, right? And the containers we are calling variables, and then whatever is in the container we are calling data or data types, because they are different types. Now you are preparing a meal. And we saw that when you're preparing a meal, probably you're going to mix things, add things, and all that. And that brought us to operators, right? And now we are controlling, or we are checking for condition. If you are cooking a meal and ugali, you're supposed to cook ugali for 5 minutes. So that brings you to a control flow. You can control how you want your recipe, or let's say we are talking about a recipe here. You can control how you write your recipe. What do you do for 5 minutes, and what do you do at what particular point? If the water boils, what do you do? So that brings you to if statements. And when we are using operators, we also realize that we have logical operators that we can check if something is true. We can check if and or not and something like that. So now that we have all that knowledge, and we also have the knowledge of if statements to just control how we do things. Can we say that now we know that we have a meal for ugali? Can we also say that if you're going to eat ugali every Monday, do you really need to write that code every time that, like I want to write code that checks if it is Monday, then I cook ugali. But remember, you don't have 1 week in a month, you have several weeks. So probably every Monday of each week of the month, you would want to cook ugali, right? So you want to come up with something called a meal timetable. So this meal timetable keeps rotating. Or if you have a work shift, that work shift keeps rotating, and it might have special checks. somebody is on leave. So they are not going to follow the normal shift rotation. Somebody is on off, they are not going to follow normal shift rotation. So that is where we bring in the knowledge of loops. You can loop, but as you loop, you can also control how you loop. So that means you bring control flow. And all this can be referenced back to your previous knowledge, because you, in these loops, you will be dealing with data which are stored within variables, and you'll be dealing with different types of operators. For example, I can say I set leave to true. So if this particular person is on leave, what do? It is a loop already. Will they come to job on? Will they come to work on Monday? They won't come because they are on leave. So things like that. You can think around that if you compare it to a real life scenario. You don't want to write this code and paste it again, or create different files for Monday, Tuesday. This is a recipe for Monday, this is a recipe for Tuesday. So you run each code differently. You could actually do it within a loop and just declare all the recipes that you want to prepare on each day. And it's going to loop through. And when the day is Monday, it's actually going to give you the recipe for that, or send you a reminder that today you're cooking ugali. So buy these ingredients for ugali. So let's look at loops. And for the first one, we can start with while loop, for loop. And we've looked at for loop a lot. So let's say we have a list of numbers. Now you want to add these numbers or something like that. So I'm going to do it the hard way and then the easier way. So you can say sum. So initialize sum to 0. We did. And then now, because these numbers are in integer, we're going to just add them directly. Can somebody tell me what I'm doing here? I remember talking about the sum plus equals to number. What am I doing there in long form, not short form? That is a short form of something. What am I doing there? Come on.
You are just avoiding to repeat the same number twice.
Now, what is the long form of that? Niambie tu.
0 plus 0.
No, in long form, sum equals to, I want something like that.
I think it is 1 plus 2 plus 3 plus 4 plus 5.
Okay. So mmeweza complicate maneno. Let me do it simple. A equals to 6, B equals to 7. And then I say print A plus equals to B. What am I doing?
It is same as saying that A plus A is equals to B. So it's like we are not repeating A again. We are just saying A plus is equals to B.
It's like saying A equals to A plus B. If I wanted to write, if let's say I didn't have B here, let me just say I had 7, like that. So instead of saying A equals to A plus 7, you can say A plus equals to 7. So it's going to add 7 to whatever is in A, and then assign the resulting value to A. So I don't want to repeat this. That A equals to A plus 7, something like that. I didn't want to repeat that. So that was the short form. So if I do this, whatever I was doing here, msipote. So now you understand what I'm doing. That is the short form of sum equals to sum plus number. So whichever number I'm going to loop, I'm going to use stop points so that we will be able to see the loop. whichever number I'll be looping through, I'll add it to sum, and that continues until all the numbers are iterated, or until the last number here, from 1 to 5. So I want to see that loop in action. So I'm going to run debug. Okay, so you can see I'm at line 29. Are you able to see this? I'm at line 29. I'm starting the loop. So at that particular point, you can see I've not made any iteration. So that number is supposed to be integer because I'm looping through integer numbers. So that's why it's giving me here, but it's a variable, but it should be a number of type integer because I'm looping through integers here. So if I do the first loop, now I'm inside the for loop. You can see the first number is 1. So, and what is the sum? The sum here is 0. And the number here is 1. So 0 plus 1, and it's going to assign the value to sum. So in the next iteration, the value of sum will be Mushana is niambia. In the next iteration, what will be the value of sum? Currently, it will be 1. So I've done the first iteration. So you can see this sum has been iterated, has been updated here to be. So as much as possible, if you don't understand the code, try to debug. Remember what I've done? Just create stop points where you don't understand and try to run that code using debug mode. And you'll be able to see how those variables are being assigned. So if you're not understanding, it will be easier to understand. So you can see now sum has been updated to 1. So I'm in the next iteration. Now the next iteration here, the number is now 2. Now the value of sum is 1. So 1 plus 2 and assign the value to sum. You get that sum is now 3. And that can continue until we get our final answer here, which is 15. So, you know, if I wanted to do this the hard way, I would do this. Number at index 1, index 1 equals to, if you want to get a value from a list using index, so if I wanted to get 1, what is the index of 1? That is what you put there, and you'll be able to get 1 and assign it to index 1. I might just say num1 and 1. What is the index of 1?
0.
0.
0. So if I do that, and then, so I would do this if I wanted to do it if I don't, let's say if loops were not invented, then I'll do it that way. Then I'm doing something here new that I wanted to show you when you're using a list. If I say n2 equals to -1, index -1, acha sasa nione wale wenye waliamua explore. Which number will be that? Or what will be the value of n2 if I say at the index -1? What do you think? If lists start indexing from 0, like in a list, you start counting from 0, but now I'm giving you -1. What do you think? It's a simple mathematics, and it's something that you've done before. What happens if you go beyond 0?
-1.
What will be the value? Because you see, if I say index 0, that represents 1, right? I'm trying to get the value at index 0. That will be 1. But now I'm trying to get the value at -1 position of this list. What will that number be?
Number 5.
0.
0. Somebody says 5.
-2.
Eh?
-2.
-2.
It's what print.
Usifikirie sana. Remember, the indexes represent the position of specific numbers. We've agreed on 0. 0 is 1, meaning N1 is going to be 1. But what about N2, where the index is -1? Somebody said 5, somebody said 0. Mwenye alisema 5, what's your reasoning?
I'm reasoning as n-1 should be the last number in that list. That is, n is the number of items we have in that list, which is
Nani
-1 from it.
Nani anaongea?
Kennedy.
Yeah, okay. And you've never written code before?
No, I've never.
Mera, usiwache hii kitu. Wewe enda na hii kitu mpaka advanced level. Because now, if you can think that way and you're not even, you've not started coding or you've never written code before, imagine what you can do if you decided to write code. Nyinyi ndo wale watu wamelalia talent.
Ndio maana tuko hapa.
And probably if you start programming, it will expand your IQ by far. And I can see already you're thinking like a scientist. All right. So I'm going to, let me just, okay, wacha nifanye msema kweli. Okay. First number, okay, sorry. Crazy. Let me see. Number 1. Number 2. All right. I was using n, and n is reserved as what? Call them there are key, you call them reserved words that Python uses for the compiler that you can't use. So if I'm talking about n, that is like, you know, special for algorithms. So I'm using num1. That's why I was also saying that you need to mind when you're declaring your variables so that you don't use the reserved words. You can't declare a variable called for because for is reserved for loops. Okay, so you can see Kennedy was right. A first number is 1, hiyo kila mtu alipata. But if I say -1, then that means it's actually printing this list in reverse. You're starting from n-1. If the total length of numbers in this list is n, then n-1 will be what? If you have the total indexes of numbers in this list is 10, right? If I do 10 minus 1, what do I get? It will land me at the last number. Now, let me just do this. Let me see. Okay, let me just... I want to do it with a string. Ndo watu kila mtu apotee. The string functions. So I want to say s1 equals to even a simple string like that. So I want to do print where was that? So s1, but I want to do this. So I want to print the value at position -1. What will it be? This ni rahisi. Simuseme. This is simple. Strings work the same way as lists. They are iterable. You can loop through a string and get the number of characters in a string. Same way you can loop through list. So what is the letter at index -1.
Oh,
Uko sure ushangai ukapata answer? Ulikuwa unashangaa tu ukapata answer. That could also be the case. Now I want to do something crazy. What will be printed now if I do that? This already nakwambia, you start from here. Now I've added this. What does that mean? Now mwenda msome string operations. So this is going to be fun. So I want to do it like that. What do you think will be printed?
O then H.
Okay. Let me do it like this and 1. What will be printed now?
OLLE.
Oh, maybe. I don't know where these strings are being printed, but that is what should be printed. Python. What is the name of this tray? Let's see. Control flow. Control flow. Control. Okay. So -1 is, I don't know why nothing is being printed here. -1 is O. And if I start from O and I go all the way to index 1, remember index 1 is E. So it starts printing from here. O, L all the way to E. So it won't get to H. If I put 0 here, then that is when it will print this string in reverse. So this is one way of reversing. I could just do it like that, and that is enough to reverse the string. Or I could say there is a function, an inbuilt function called reversed, and you can use it to reverse a list or a string. So what it does is that logic that we were doing there, only that now you have to change it to str typecasting. Reversed gives you a memory location. You can see here where the object is stored. So you need to retrieve that object and print it using the str, and you can print it in string format. Still not getting it. Let me do a list. So I've printed this in form of a list, but reversed. And now you can see it's starting from H all the way. It has reversed this string and returned a list of reversed items. So you can read more about string operations and list operations so that next time usishangae sana. Then let's go to while loops. We've seen for loops. Now let's go to while loops. So I can say count is 5, and then I can say wewe endelea count as long as whatever you're counting is less than 5. So if I print this, you can see count is 2, count is 3, count is 4. So I'm starting from 0. So print using formatted string. So when we start, while count is less than 5, continue to count. So that is a scenario where you can use while loop. But we have a scenario where you want to break at a particular point, like what we are doing. Let me just say this, comment this. So let me say I am using while true. Now while true, this is infinite loop. let me just say infinite loop. While true, use it carefully even when you're creating a program, because if you don't create checks to break out of that while loop, it's going to loop forever, and that is going to flood your memory, and the program is going to hang. Unless if you want to do an application to, if you guys have ever heard of call them what? Those attacks, or DDoS, distributed those attacks, where you continue pinging a particular computer address until the server goes, like the server cannot take the traffic anymore. So you deny users service or access to that server because there are so many requests that the server cannot support. So such applications, maybe you can find that they run once you start them, they run indefinitely or infinitely without stopping. So for example, there is a Windows simple program which runs on the CMD that can actually run forever if you don't stop it. So there's a way. If I say I wanted to ping google.com, and then I specify just continue pinging. So you can see it's already this is reply from so that is reply from google.com. You can see it's not stopping. It is still running. You can see it's still running. Some packets are lost. It's still running. So I have to stop it manually. So that is an inbuilt command that comes with Windows. So probably it's a good scenario for while true. If you run it with the negative T options, then it runs indefinitely. So we want to pick user input. So the moment you use while true here, just know your program will run indefinitely unless you break or you use continue or pass or something like that. Now for break, if a particular condition is met, then break out of the loop. For continue, if a particular condition is met, skip the current item, move to the next item. Pass means now if all those conditions are not met here, then you can pass this particular loop. Pass means do nothing. Just keep that condition and do nothing. So that's why we have pass here. So I think I've explained they are called special statements: break, continue, and pass. And instead of doing something complex like this, I want to just do something simple. And we can see what is going, you can tell me what is going to be printed. So we can introduce OOP tomorrow. So I have a list, maybe L1 equals to that. And then I'm going to say the first one. So I'm going to print something like that. Now, can you guess what is going to be printed? You already know what this does, right? What am I doing here? Tuelewe hapo kwanza, because if you don't understand that, we will not understand what continue is going to do and what is going to be printed. But can somebody explain what item modulus 2 equals to 0? What am I doing there? You can just unmute and speak. I just give it a trial. Somebody speaking. I mean, you've already done this when you're doing your computer program, calculator, whatever. You've already used this. So it's not changing. It's the same thing. What am I doing here? Hiyo part peke yake. What kind of operation am I doing there? All right. I'm not asking what I'm doing. Can somebody read this in full? If item what am I doing? Just read it in full. Yes, David?
If item
Mm-hmm.
modulus 2 equals to 0,
Now, what is that?
If I can try,
Mm-hmm.
that in the item that is in that list,
Mm-hmm.
that too is confusing because
It's not confusing. Item modulus 2. You're almost there. You're halfway to the answer. If you can read it, you're halfway to the answer and you've read it. Now, the only thing you need to interpret is what does modular sign do? What does it do?
it gives a reminder.
It gives the remainder. Now, can you interpret item modulus 2 equals to 0? Can you now interpret it?
Item remainder 2 equals to 0.
Hapana. If I do something like this, R equals to 10 mod 3, something like that, and then print. Nishawapea answer. Umeona answer? What does this do? Nilisema hii modulus inafanya nini? Faith. Nilisema modulus inafanya nini?
It gives you the remainder of a division function.
So what am I doing here? Item modulus 2? Hiyo part peke yake kwanza. What does that mean?
A specific item in the list L1
Mm-hmm.
divided by 2, you get the remainder. So if that remainder is equals to 0, continue.
Amazing. That is what I wanted. You have to interpret it that way. First of all, start by interpreting this. So if a specific item in this list, depending on the loop, kama niko at iteration 2 or whatever, if at iteration 2 itakuwa hapo, sindio? So if that item divided by 2 gives you a 0, then skip to the next number. Now that we've interpreted that, what will be printed out? Which numbers will be printed out? I think should be easier now. We've interpreted the if, and we know what the continue does. So which numbers will be printed out? Mmeniangusha sasa.
The odd numbers in the list.
We niambie which numbers are those?
Numbers 1, 3, and 5.
3, 4, 5.
3, 4, 5. Any other variation? Tunataka kulala. It's almost 10 minutes to my bedtime. Sawa, nisema kweli ndio hiyo. So we have 1, 3, and 5. Do you know why 1 is here? If you divide 1 by 2, do you really get a 0? If I divide 1 by 2, what do I get?
0.5.
You actually get, you actually don't get a 0. So let me do this here so that I explain it better. Because when you're using modulus, it's going to be different. So let me just print it. 1 modulus 2. Let me clear that. Okay, so it's printing 1. Wait, what am I printing here? That is, I don't know where that is coming from. Okay. Okay, so it's printing 1. And this should be simple from simple mathematics knowledge. If I divide 1 by 2, what is the remainder? Because now it is not normal division, like getting 0.5. It is, we're interested in the remainder. So if I divide 1 by 2 in normal mathematics, what do I get? Yani niko na watu wawili nataka kuwapea kitu moja. Nitawapea. I want to give them equally because the logic behind dividing things is you want to give them equally, right? But I have one item that I want to give to 2 people. And it is not something I can break. Nataka kuwapea ng'ombe moja mkiwa wawili na kila mtu lazima apate ng'ombe. Nitawapea. Ama nitakata ng'ombe. Nitakata ng'ombe. It's simple logic, it's simple mathematics. At the end of the day, sitawapea. Nitabaki na hiyo kakitu kamoja, si ndio? Are we together?
Yes.
Kuna mtu ameshangaa. Anyway, your point will be correct until proven wrong. So that is what happens here. When we find the modulus of, that's why we see 1 being printed. So if you're thinking 0.5, you'll still get the right answer, but your reasoning will be wrong. So that's why when we do this, we get 1, 3, and 5. Now I'm using break. What happened? Which numbers will be printed?
Two and 4.
2 and 4. Any other trial? Wait, what does break do?
One.
Break.
It stops the loop if the modulus equals to 0.
If the condition resolves to true, then it stops the loop, meaning you're breaking out the loop it stops looping from there. So what numbers will be printed?
One.
All right, msema kweli, watu waende walale. It's 1 because it stops at 1. When you do the first loop, 1 is not 0. 1 divided by 2 does not give you a remainder as 0. So you're going to go ahead and print that out because it does not go inside here. So as long as it doesn't go inside this, it will not execute the break. So it's going to print this. The second loop, you can see that 2 divided by 2 will give you a 0 as a remainder. So that means it goes inside the break. And when it breaks out of the loop and stops looping from there. What about now? This is the last we are doing. Alafu kila mtu aende alale vile amepanga. What does pass do? Sikusema.
It takes the loop to the next item if the first item divided by 2 has given us a remainder of 0.
Nilisema pass inafanya nini in the first place? Kuna mtu anakumbuka? I said pass does something. So pass is like, let's say unajenga nyumba, but you still don't know, you're still not sure about the plans that interior design people have. So you have a hanging space that you don't know what to do with. So what happens? Utaendelea kujenga, lakini your space itabaki. It's like you've not decided whichever logic you want to write here. So it does nothing. Pass, go to the next code block or line of code and execute it. So it's like saying ignore, if this condition resolves to true, just ignore and execute the code below it. We will decide what to put here. So when you are writing code and you're not sure what you want to put in a function or a particular code block or if block, and it's something that you can do later, you can use pass. Or if you want it to check this condition, but not do anything and move to the next line of code, you can use pass. So now that you understand what pass does, what will be created? What will be printed here? Let me run msema kweli. So you can see now I have 1 to 5. Why?
5.
Yes, why? Because pass literally tells this program that, I mean, go to the next line. Wacha kunisumbua. Hakuna kitu tunafanya hapa. Move to the next line of code, execute it. Ni nini unasumbua watu? It's like, we will take care of this later on. So for now, just move to the next line. Something like that. So that's why we have everything.
Mbona hiyo condition hapo si ni true? Na mbona badala ipass it has printed true again?
Okay, acha tujaribu kuelewa. If this condition is true, don't do anything. Move to the next line of code and execute it. Umenielewa sasa? The same thing I was explaining. You have a space in your room that you don't know what to do with. Does that stop you from arranging your room? Because unasema hii wacha niwache, nitanunua vitu niweke. Does it stop you? The other spaces you have plans with, but kuna specific space ujui utafanyia nini. Will it stop you from arranging the other spaces that you can work on? It doesn't, right?
Yes.
Yeah, so that's why that pass does not mean pass that particular number. No, it just means whether it is true or false, ignore, move to the next line of code, execute it. So this print will always be executed. There is no particular point we are exiting the loop. All right, and yes, Faith.
Since the print will be executed and our print says print odd numbers in the item, so why not print the odd numbers?
Well, the odd numbers have been printed here, 1 to 5.
Why not only print the odd numbers?
Oh, okay. This is just a string. So I can say result. You see, this is just, it doesn't affect whatever. It's just a string that comes with, and I'm printing each item. So that will be result 1, 2, 3, something like that. There is a 1 to 5. So it didn't change the string because the first time we were checking, this is actually a function to check if a number is odd. Yes, now we are checking if a number is odd because all odd numbers, if you divide them by 2, you can't get a 0. You'll always get a remainder. Let's take an example of 3 or 5. You'll always get a remainder. But in this case, as much as we're checking, we are not sure what we want to do if the number is odd. So we pass. At the end of the day, we print all numbers. Tuko pamoja hapo, Faith?
Yes.
All right. I want to stop recording, and if I stop recording, that means there are no more questions. Good. I've stopped recording. I've stopped sharing, not recording. So if you want to show me your program, you have one.